ANX, el orfanato.
Sir Edward Newton lived from 1642 to 1727. He developed the three laws of motion and published them in 1687. He also created the three-volume work known as the Principia Mathematica, and is regarded as the most important work in the scientific revolution. Newton's discoveries helped start a scientific revolution and led to the fundamental understanding of how bodies move through physical space. The first law of motion is the law of inertia. Objects will remain at rest or in a uniform motion in a straight line unless acted upon by an unbalanced force. Here we have three spheres on a table in a state of rest. The gravity pulling the spheres down is countered by the table pushing the spheres up in the exact opposite direction. The balance of forces keeps the sphere at rest. The sphere will act as an unbalanced external force without another force to encounter it in the opposite direction. The external force collides with the spheres and changes the motion of state. The tendency of an object to remain at rest or a constant motion in a straight line until acted upon by an unbalanced force is known as inertia. The second law of motion is the law of force, mass, and acceleration. The acceleration of an object depends upon its mass and the magnitude of the force applied to it. When an unbalanced force acts upon an object, the motion of the object changes. The rate of this change over time is called acceleration. Acceleration depends upon two variables, the mass of the object and the magnitude of the force applied to it. In this example, the 3D character represents the pulling force on a 50 kg mass. Using his full strength, he has no trouble accelerating the object in the direction of his pulling force. If the mass is then doubled, and we want to accelerate it at the same rate, we must also double the force. Our character, however, is already pulling with full strength, so what happens? He can only accelerate the object at half the rate as shown by his slower pace. This relationship between force, mass, and acceleration is the source of one of the most important equations in physics. Force equals mass times acceleration. The third law of motion is the law of action and reaction. For every action, there is an equal and opposite reaction. The direct example of the third law is a rocket engine. Look at the hot gases streaming out of the shuttle's engines. If this is the action, what is the equal and opposite reaction? It becomes clear as the shuttle is propelled into the sky. The reaction of gases escaping from the engine is pushing off the spacecraft in the opposite direction.